It's a funny day today. I've got a lot on, including a doctor's appointment, and so we'll start this at time shall we start this? 6:30. Currently running my bath water. Right. This is coming from a trade customer, and he can usually sort things out, but this one's eluded him. So I said I'll have a look. I can't promise anything. We can only fix 99% of stuff. There is a third-party circuit diagram floating around for these, which is certainly better than nothing by a long way. And the reason I've dug this out, probably out of sequence slightly, is because I've got a couple of mics to wire. So I could do with a set that's Cybernet type wired, which I think these are, just to test them on. I've got a mic test jig somewhere. So this follows on from doing the SMC Oscar 272, which worked really well after bringing it back from more than the dead. After a 10-meter conversion, and then the set failing on top of that. So this is the later version. If you get the one with the yellow meter, that's the earlier version, and of course there's always the I think this one's better than that, but we've never tried two side by side. So to be honest, it's pretty filthy inside, like it's been sat with the lid off for 10 years. The power connector is an unusual type. You can make a Cybernet 2-pin one fit in there, but it'd be then non-polarized. It is the Workman's something or other. Workman are a third-party parts supplier from the United States. I did try and open an account with them, but the minimum spend was $10,000. So no, I don't think we're going to go down that avenue, especially at my age. Might have done if I was 29. Why is that linked out? This is where we find another set off the shelf, one of our own sets, just to see that all these wires that are there should be there. So we've got a Serpent UK, no, it's a Planet 2000 on the shelf. But I've no proof that it's a Planet 2000 because the badge is missing off the back. It could be a communicator with a knob shoved on it. But what it is the right version. I don't think this is a Planet 2000 because I think it would have a yellow meter. Oh well. That's what it is now. It's got one wrong screw in it. So this will be a forthcoming attraction. This looks better condition than the customer one. Oh, good grief. So someone's taken the relay out and they've put another relay in, But in actual fact, you can get the relay right. Now, this is what I was looking at. Why is that linked out on this? It isn't linked out on mine. That is there. They've bodged a trimmer capacitor on the back of it. There's a lot to do to this, isn't there? To get the, I would like to have the right relay, or if we can only get a wrong relay, to actually put it on stalks on the proper side of the board. That's an, yeah, right. It looks like it's been somebody's play toy. So you know what we'll do? So that goes so we've got an extra resistor there, which shouldn't be there. Don't know why that wire's so corroded, but it is. So that resistor needs to come out. Let's get rid of the jumper wire. So that's there. What I'm going to do is, I'm going to really have to cut that off. And put that back in. .49. That's wanting to short across there. So whatever that was all about, I'll have to get our notes out because I can't remember. So just have another visual scan. The filters in place. The ceramic filters in place. No, I can't see any other anomaly. Right, time to power it up then. I'll use the PA speaker rather than the... That is another thing I need to talk to you about. You know, when a CB radio is in PA mode, I do want you to all know that they don't transmit anymore, because you've turned it from being a CB radio into a public address amplifier. So all it does is talk into a loudspeaker. We're using an extension speaker. I've shown you the type before, the SW711. There's the Palmer 811, which is the same thing. These have been discontinued about 10 years ago. Realistic did one. It's a 4-inch square, 4-inch by 4-inch, 2-inch box. I've shown you these countless times. I like them. They're too big to go in modern cars, and you tend to find that, well, they were discontinued because of that. But they do work well. And so when I switch to PA speaker, it's actually an extension speaker, which is 8 ohms, which is shoved on the wall here, and that's what we use. And that's the extension speaker we use when we do the on-the-air test. But don't think you can transmit into another radio when you're in PA mode. It doesn't transmit and become a PA amplifier. So very useful having the PA facility for testing things like this. I don't know which socket is which. On my one, I can still see that the upper one here is PA, and that's what we're going to test first. I'm going to hook the test gear up. I should have read the customer's notes on this, but we'll find out, won't we? That means going in another room. Right, switch on. It's 13.8 volts, and it's powered up. It's on channel 20, and it looks beautiful. So we'll switch it to PA. Cybernet wired mic. Testing 1 2 3 4 5 5 4 3 2 1. So that works. It's on the volume control. And we'll get our clipboard. So I may not be able to fix this. And a sheet of paper. It says on the front, it's an LCL doesn't say anywhere on it LCL, but it is an LCL. I really think these work well. Some people say they bleed over boxes. I knew somebody in a town who asked me to get them one as a wedding present, so you know, they can't be that bad. I just think they're so complex to set up that most of them aren't set up right, and this is the issue. Meter lamp works, PA works. How about that? Nothing like ticking a few boxes there. So we'll put it back into CB mode. I've got we haven't got any audio because that's not in the right socket. So we've got receive audio. Make sure that's up. That we've got that up. I'll put the signal generator on. We'll do this topsy-turvy and just see whether we can hear anything. This will tell me whether the synthesizer is running. sent in a relatively modern Midland set. Something like a 98, something from the 1990s, I think. Well, it's certainly not receiving my signal generator. So is it transmitting? I've got it on the roof aerial. I've just heard that come over our tannoy system. We've got channel 20 on a scanner. We've got channel 31 on the base station in the airing cupboard. So we can hear our signal generator, and it sounds awful because the receiver is not set up right. Transmit. Yeah, it's transmitting now. I'll have a look at the customer's notes. I'll pause the video at this point and see what the customer says about this set. Okay, so he's got another one. I was modelling it with another one which somebody put an illegal modification, which is absolutely bizarre on sets like this. I have a Communicators NI440DX that needs your expertise. I've repaired one of these. He's got 3. This one's so out of alignment that I've not got the equipment. You have to sort it out. So that's what that's about. So it was basically working. So I mean, this kind of area is the... I went away to do that and to go and get the notes. I'm going to have to pause the video because I've not brought the notes with me. So this kind of area, what's this transmitted audio? They're trying to get about 1 million kilohertz deviation by doing whatever they've done, or what. I just don't know. I'll just go and get the notes. Right, we'll start again. So I've got the notes for the Manor Kestrel, which of course is the same thing, but probably just has the yellow meter. Right. So we've clearly got no added resistor on this one either. So VR V15, I think it is. Oh, it's low power. So what's all the jiggery pokery around there then? I don't know. Right, picture in picture on. Turn the volume down so it doesn't annoy people. And we'll start with the transmitter. So it's going to be the receiver that's the naughty bit. I think we've been on half an hour, I'm sure, so I think we can safely do an alignment. I don't know what I'm looking at with the remote in my hand. I'll switch some other gear on. Okay, so it's right now. We'll get the clipboard. It's doing 3.3 watts. Just check the other channels. 3.3 on 40. 3.3. They don't normally do 4 watts, by the way, these. Add 0.4 to anything I tell you, because of the way this test set works. With it being selective, it's only looking at the frequency we're transmitting on, not the interference. I know that's the important thing, whereas everything else is going to add the interference in as well. So low power at the moment. Just go into back to channel 20. Low power, where's that? Don't tell me it's on the back. Yes, it is. At the moment, low power's doing 25 milliwatts. Now, of course, that could be because of me altering that modification. Back to normal power, with current consumption is 1.4 amps. I think that's high for the power output it's doing, but then these sets draw more current than most other UK FM sets. The deviation according to this test set, wallow, is 1.8, but we'll verify that and adjust it on the test set behind me. We're not going to do the VCO on this. Frequency, that's why I need the remote. $27,79042. So that does need to come up. It's lower than 0.005%, which is what we're trying to be better than. RF meter is actually supposed to be, yeah, it's 4.2. So that's not right. And both the sockets work. We'll come back to receive when we get to receive. Okay, so back to the transmitter tune-up. So we want to be on the 30 watt scale on our test set. We need to see whether we can get a bit more out of this. That's definitely peak. That's definitely, so far everything's spot on. So we're doing 3.5, maybe a bit more than that when it cools down. Dare say it'll be 3.6, which if you add 0.4 to it is 4. Don't ever worry about all this power business. It makes so little difference. The difference between 3.6 and 4 watts, you know, maybe feet. I've done tests. We did an amateur radio test. I think we went on 28 megs, and we went to Scratchy Corners some years ago. You can always repeat tests like this, and we went from you know, like 4 watts to 45 watts to show the difference or the lack of difference, you know. So we can always do things like that with us, you know, having those kind of licenses. Right, so we're happy with the transmit. Now, the deviation we'll come back to. Oh no, shall we do it now? Yeah, I'll do it now. I'll get that out of our hair right away. Deviation. I need to change glasses for this one. They're annoying, these presets. They're vertical. Deviation is that one. I'll put the tool in ready. Right, let's see what we've got. Wow, it's absolutely spot on. Could have been 2.3, but we're splitting hairs. So my test set's lying today. See if we can bring it on frequency. That's pretty normal enough on these sets. The frequency trimmer next to the reference crystal by the phase lock loop chip. I'm not going to set it slightly high just in case we're still warming up. $27,79125. Oh, I'm not showing you that. Just go a little high. There we go. That'll do. Because by the time this has been on an hour, it's probably about 127. So we've now got 3.5 watts. Well, let's go back to, it's cooled down a bit probably. It's 3.5. Right, that's that done. Now, can we alter this situation with the low power? Yep, no problem at all. 400 milliwatts it is. And it's now 1.38 amps to do a little bit more power. So it just shows, you know, we have tuned it up a little bit. Meter. It's just over the 4, so I think it's fair to just pop that down a fraction. There we go. So I think that's the transmitter covered. Okay, so we'll now look at the receiver. See what we've got at the moment. Am I on frequency? Not quite. Okay, so we are now. And we'll go from the extension speaker into the test equipment speaker. The reason I've done that is in case there was something really malfunctioning on the radio. I don't want to put volts up the test gear. So looking at the synod meter, at the moment it's doing 0.7 microvolts. That's not outstanding, it isn't rubbish. I'm sure it could be better, but it doesn't sound right. For 10 dB it's 0.66, and for 20 it's 0.95, which is interesting. Squelch. On full never opens, and at threshold interesting. something happened. Right, we'll do that test again. So it never opens on full squelch. That's interesting. So when squelch has happened, it's not returning. Right, so let's see where the threshold is. There's something wrong with the squelch. Never opens. And you've got to rekey the set to make it start receiving again. So it's just got a blank. Right, well, we'll go through the normal tune-up and then we'll see what's happened. Nundra's stuck with it. So we'll go for the detector. Let's put that up on the screen. It's not your normal IC on this. That's well out. It's which one's the right peak. And the other thing, you've got this, if I remember rightly, this is the level of 10.24 that goes to the IF. You see how it's really affecting. So is it that one we want? Well, it looks like the upper one. Just look at some of these IFs. Yeah, that's our killer. That was miles out. Just look at those other peaks now. Let's check that one. We'll come back to all these, but I think we're set with the detector now. I said it sounded awful, well it did. This might fix the squelch problem, it might not. Okay, so let's look at the synod meter. I have less signal than that. Bit more signal to that one, which is one of the IFs. Is that where it should be? Sounds like it should be. And then back to the detector. No, we must be on the wrong one here. No. We're on the wrong one there then. And back to synod. There is something amiss. It ain't just tuning. Oh, we haven't done that hidden one, have we? Set squelch again. So once you've set squelch, nothing will bring it through. Just see what it sounds like from my walkie-talkie. Testing 1, 2, testing 1, 2, 3, 4, 5. Not normal. 1, 2, 3, 4, 5. It sounds normal there.
1 key, 3 key. See what it sounds like.
Testing 1 2 3 4 5 5 4 3 2 1.
See, that sounds all right. There's something amiss. So it appears to be around this IF, which is L what? 5? Can't see this. I think it's 15. So let's look at the circuit diagram. Good grief, I'll need about 8 pairs of glasses to see this. So we're here. That's our meter preset from there. Now that'd be an interesting test. We'll look at the meter. Let's set the meter up for S9. I'll unkey it and rekey. So we've got a signal. And see if we can set them. Oh, that's what's going to happen, isn't it? We're going to set the meter, which is that one. So it's not liking it, is it? Is this going to be this coil again? We can't get full scale deflection on the S meter. So there's a dead giveaway. So that malfunction, it might sound right, but that malfunction is still there. So when I turn the squelch, yeah, it's something round there, all right. And it could easily be one or both of those two transistors, 12 and 13, that need to, in order to get turned on, need an extraordinary high input instead of like 0.7 of a volt. So that can be an issue, so we can swap those. I'm just looking whether there are any electrolytic capacitors in this area. And you see the squelch comes off the next stage of this circuit. So you've got the transistor we're concerned about here, 12 and 13, then it goes into the next transformer, into the two diodes, and then it goes into this IC. So it doesn't use the normal kind of FM IC, and it uses a double diode discriminator. So I think we need to start by changing transistor and 13 by substitution. So I think they're going to read right on a tester, but they're not going to actually, it's a triggering thing. So I have to come back to that in a few hours. Right, so many hours later, I seem to have lost my picture-in-picture camera, so we'll switch that off. Many hours later, 2 o'clock in the afternoon, I've got all of 10 minutes, so let's take out, I've already unsoldered it, and hopefully transistor 12 will come out. Making sure I know which way it came out. Yes, the same as the board showed, and 13. Good. I may as well change them both, because they're both in a part of the circuit that could cause this. Don't normally find two SC1815s fail. It's basically a plastic BC108, which is basically a BC238 in European parlance. So we've got some new ones here. So I want to see, oh, I've got the wrong meter. I want to see if anything reads amiss. So transistor, gain of 167. Gain of 260. Slightly different lead spacing. They're being pre-formed into a fanned out type of thing. Anyway, we'll get it in. So solder that one in, and solder one leg like that. You naughty transistor. And the second one. $160. So our first one was 168, the second one was 160. So what was it, about 260 for our replacement. But neither of them are reading as faulty, so you know. $348. So certainly more gain, and these are genuine parts. Well, that didn't work. I I don't expect it to be any different when I switch back on, but I'm doing the right thing. Could have a duff filter. Right, switch back on. That's definitely changed the tuning. Turn the signal down. Set the squelch. Squelch not working still. But the set does receive once we've triggered the squelch. The set does receive once again, which it wasn't doing before. Just check this detector. I realise I haven't got picture in picture on. This has made a difference. Tuning is in a different position. So we're going to go into transmit. Testing 1, 2. Go back to receive. Turn the squelch down. Testing 1, 2. Testing 1, 2. Testing 1, 2. So we have gained ground there. I mean, there's every chance that the squelch has a fault and that the receive had a fault. I've fixed the receive. It's now not budging from there. So just for now, we've got 0.58 microvolts, 412 dB synad. So I'll just see whether we can improve on it. I know I've done the tune-up. Probably about where we're going to be. The one they don't want you to touch. Yeah, so the squelch doesn't work. But now we're going back to a normal receive. So it could be simply the preset's faulty. So where's the preset? Preset is
down there. The preset is affecting it, but the squelch doesn't work. So it's certainly muting the speaker, but it's not getting a signal to make it do anything. Now we've got two capacitors here, and it would be sensible just to change them without doing any further clever tests. So 36 and 102 by the looks of it. You'd think they'd be in the vicinity of that IC. Well, it looks like 36 anyway. It's on the base of transistor 19. Let's find transistor 19, 17. 12, which is there, 10, 13. Actually, we've got it on here. At the back. Just to make it more confusing, transistors are given the same Q designation that integrated circuits are on this product. So the IC is Q18. Just see if have I got our one still out? Yes, I have. I'll just see, because it's better condition, our one. It might be easier to find the part. Yeah! Oh, it's there, it's hiding. I saw it straight away on ours. Capacitor 102 and what looks like, it could be 96. .98 is next to it. 102. So they'll be the ones. They'll be the ones. Turn the power off. Is that supposed to be linked out? Yes, it is. That's why you have to have more than one set. With a dot. So that's 10 microfarads, 16 volts. Now that's reading faulty. We'll get a new one of those in. Slightly higher voltage,
25 volts. So negative to the dot. You'd expect the dot to be positive, but that's why you've got to be absolutely sure. I think we've had the odd capacitor not being right in these, but they're not a set that is prone to capacitor failure. In fact, they're not prone to anything except being not tuned right. You know, as they've got older and they've gone out of alignment, just down to old age and poverty, with them being more complex to tune and unconventional, they just don't get tuned up right. You can imagine this on eBay, couldn't you? Well, it works great. Squelch not working properly. Some minor fault, you know. So what's this one? It's 1 microfarad at 50 volts. And that other one looked like there was a bit of gunk coming out underneath. Oh, it's come off. That's reading fine. We'll put a new one in. So you only need something like that, the capacitor to be leaky, and that can be shunting the squelch triggering signal to ground. So what's the circuit say? 1 and 10 microfarads. So I'm sure I've got the right ones. It won't be the transistor because otherwise it wouldn't mute the radio. Now, this is all I've time to do on this session. Power back on. Put a signal on. Set the squelch. And no difference at all. No, so that's that's a faulty part we've changed, but it's not fixed it yet. We'll look at a few more obvious things and then we'll have to call it a day. So come back in a bit. Right, so back with you. I've had to borrow a part off that set I just showed you. We don't have a scrap chassis. This coil, L16, I think we came to the conclusion it was. So on this set, you haven't got a clever FM chip. So you've 2 diodes there. You've 2 diodes there, and I've changed those because it seemed that we've got no squelch operational and we've got no meter operational. I haven't checked the squelch yet, but the meter's now reading. So it seems to me, therefore, that we've got something wrong here. We haven't got a feed problem because the rest of the receive's working. I've changed those resistors. They're read all right. I put 2 there, new ones in, just in case they weren't working under load. So 22k and 22k. And we still weren't getting the S meter, so it has to be because on the primary of this coil, because it's a transformer, isn't it? It's got a primary and a secondary. On the primary side of it, you've got the takeoff for the FM demodulator. But on the secondary side, you've got this bit, which is one diode goes to operate the squelch circuit. So it's got an AM detector by using a diode, and then it's got another AM detector to do the squelch. So the germanium 1N34 diodes I've fitted. We've changed the two diodes, and that reads them. Now the meter we knew was fine because it was on the RF, absolutely fine. So it had to be the. So we've unsoldered L16 from that other set, and now I have the meter reading, as you can see. So I can put S9 on it, which is what's showing, and now hopefully we can set that wherever I've put the trim tool. There it is. It's caught on the curly cord. There we have S9, just as it should be. So I'm just going to. It is annoying not having the power connector. I've got one left, and I'm not going to take it out of its packet. Right, so we're just going to check these IFs one more time. So we've got two faults on this, if you recall. We've got the two transistors I've changed, which have brought the receive back working, because remember, as soon as the squelch operated, it didn't come back to receive, and I don't know which one was faulty. Both read right, but the new ones were higher gain, and it must have been an issue in that direction. So that sorted that out. But with the second fault, with the duff transformer, how does that become duff? I don't know, but I think this has been very damp, and it's just one of those things. So we're just going to absolutely triple check all these final things. I'll do the detector one more time, because it's late on and we really need to do a scratchy corner test, or otherwise it's cost us another day. So that's definitely peaked the detector. I'll just do this one with a lesser signal. Let's look at the. We'll go to the synod meter again. Yeah, we needed that adjusting. We'll have to recheck that S9. That is the. Isn't that the drive to the IF? It is. That's fine. That one. See, that's now helped with that one as well. I won't need to touch the front end because that's not going to be affected. Just check I'm still on frequency. I am. The one you're not supposed to touch has been affected. I started to think I got a duff filter as well, but no. So they are unconventional. They're hard to set up, but they work great when they work. I don't think we need to touch any of the others, but I'll just be sure. That's it. So for 12 dB, we've got some figures now, which may be different to what we had before. I've got all my notes all over the place now. So with it under fault condition, we had 0.7. It wasn't crap anyway. It's now 0.62. So even with the faulty receiver, with the two duff transistors, and this coil being open circuit, but you see it was affecting the squelch, and it was affecting the sound of it. So for 10 dBs, we've got 0.55. And for 20 dBs, we've got 0.95, which is exactly where it was before. So now, because it never opened, let's play with the squelch. I haven't tried this yet. So 1, 3, 10, 30, 100. So it's not coming in at all. Let's hope there isn't another fault. I've gone and adjusted the wrong one, that's the S meter. So we'll just put that back right. And go for the squelch, which is that one. Well, I thought it was. Don't tell me we've still got a squelch fault. It's supposed to be squelch. Let's do a check to see if the squelch actually works. It does. Thank goodness for that. However, it's stronger than is useful. So I can't get it to quite how I want it, but I've got it to 210 microvolts on full. So let's hope we've got a threshold now which is sensible. So I've taken this signal generator to standby, set the squelch threshold, signal generator on, straight in. It's 0.3 it comes in at. Now these do have a good squelch. Good, really good transmitted audio, really good clarity of receive, really good squelch. There we are, we're done. I don't think there's anything else I've now overlooked. It's been so long and drawn out, I've actually forgotten what we've actually done. So he's had 2 times 1N34A, 2 times 22K. With precautionary changed, well, we had to change one capacitor because it was duff, and in finding that we ended up changing another. He's had 3 times capacitor, the small ones at 16 pence, and he's had 2 SC 1815GR transistors. And the coil, which we'll have to get that one. We need a scrap chassis. Anyone got a scrap chassis? We need a scrap chassis, or I can't. What's it worth that? Right, time to put it to bed. So quite a diagnosis. I can see why the other dealers got stuck with that, with it having the fault there, the fault with the 2 transistors, the fault here. You don't expect that many faults on one set. I just think it's been stored damp. I don't think anything's happened to it. I mean, it's effectively mould growing on that board. Right, we'll put the lids on. It's an immaculate looking set. I think that's the lid. I think these are a bigger speaker than usual as well. So just unplug the equipment speaker. That sounds alright. And finish our video. So I've actually spent all day on this apart from a doctor's appointment and a quick shopping trip. See, normally you'd say, oh, no, the squelch isn't working. It's got to be the clever FM chip, but there isn't a clever FM chip. So just like the Fidelity 1000 and all the other great chassis, it has a AM detector to do the squelch. That's a push-in screw. And they're not unreliable sets. So we had one duff capacitor, didn't we? And two which were changed for precautionary reasons as part of the diagnosis. I did this set because I wanted to do a couple of mics for a customer. I had nothing on the bench which was, you know, cybernet wired. So I thought, well, we'll do a set and then it kills two birds with one stone. That woke it up. One on a Roger. I didn't check if the Roger bleep was working on this. I'll just go on channel 31 and it'll come over our tannoy system. Testing this radio now works. Testing with the Roger bleep. Yes, the Roger bleep's working. Nobody on. Right, well, I'm hoping that works nicely because they tend to be good. There we are. Long and drawn out repair. And you say when you do training for electronics, they don't tell you you're going to get 3 faults. You know, they give you an exam and they say fix that, but there's 1 fault they've put on it. They haven't put 3 faults on it. This is what you learn as you get older. Thanks for watching.